Latitude Media, covering the new frontiers of the energy transition.
In the business and investing world, there's a dangerous trap companies sometimes fall into called the sunk cost fallacy. It's basically the idea that because you've already invested time, money, or resources into something, you should keep going, even when all the evidence says you should stop. It's a concept that Damian Beauchamp, the CEO of 8 Rivers, knows all too well.
Yeah, as we were going through the project, some of the engineering team had identified some efficiencies that could be applied into the 8RH2 design. The primary issue was that we had a lot of sunk capital.
For years, 8 Rivers had been planning Project Cormorant, a massive low-carbon ammonia production facility in Port Arthur, Texas. The plan was that it would be the commercial debut of the company's signature hydrogen production technology, 8RH2. But deep into engineering studies, the team made a discovery that changed the plans for the project.
We could be near complete with our feed if we keep the current design, or we can implement these new changes, which means some additional cost and time for the company.
The changes would lead to a new version of the 8RH2 technology called 3.1. This would be a more efficient, safer system. But implementing those changes meant missing the project timeline and pouring more capital into it.
Although we were quite a ways into the feed, we had the difficult question to answer as to whether we were going to ultimately pause and decide to implement those changes.
The choice boiled down to a classic dilemma. Should 8 Rivers stick with its current approach or risk everything on a better design?
What we realized was that we had an opportunity to really optimize the system, and so I think we all got behind that, but the primary tension was around the sunk cost fallacy. So it's been a good change, but it was not easy.
That choice is just one of the many difficult decisions in 8 Rivers history. The company has been building industrial-scale clean technology since 2008. And in fact, they're behind one of the few successful point-source carbon capture projects in the United States. That's the Net Power project in Texas. And that long history of building big, clean projects is what makes 8 Rivers unique. I'm Lara, and this is The Green Blueprint, a show about the architects of the clean energy economy. We've already invented most of the solutions needed to decarbonize the global economy, but many of these technologies are not yet commercial, and they need to get financed and built at scale. We don't have decades to get them commercialized. We have years. This week, I talk with Damian Beauchamp, president and CEO of 8 Rivers, about building big, first-of-a-kind industrial decarbonization projects.
So the co-founders of 8 Rivers decided that they were going to develop and create a company focused on large-scale industrial innovation that has longer time horizons to first product, as well as larger capital requirements for first deployments. Additionally, I think they took it on because they knew it was hard.
Eight Rivers is not your typical climate tech startup. Founded in 2008 before venture capital was flooding into clean energy, before the Inflation Reduction Act and before climate tech was cool, the company was born from a contrarian thesis about the future of energy.
8 Rivers was founded on the theory that there were lots of people doing software-based innovation or computational-based innovation, and that a lot of the larger industrial innovation was not occurring primarily because most of the VC capital was targeting lower cost to first product and shorter time frame to first product type companies.
The company's co-founders, Bill Brown and Miles Palmer, made a bold bet. Instead of chasing the easy money in software, they decided to just go ahead and tackle the hardest problem in industrial decarbonization. Their insight was both simple and revolutionary. The world has never stopped using any energy source ever.
If you look back to 1800, even biomass today is used more than it was in the 1800s. Oil is used more, gas, coal, everything is used more. And solar and wind were simply additive. Why is that? Well, population growth, and then countries that weren't as developed as other countries are developing.
So instead of trying to eliminate fossil fuels entirely, Eight Rivers asked a completely different question. What if we could use fossil fuels without any emissions?
The thesis was you needed to fundamentally redesign the system, and you had to introduce the constraint that the system was not allowed to emit anything other than pure CO2.
That constraint is what led Eight Rivers to develop what they like to call the Allen-Fetvet cycle. It's a power generation system that burns fossil fuels with pure oxygen, and it uses the associated carbon dioxide as the working fluid.
The real genius kind of came from a gentleman by the name of Rodney Allen, coupled with the practical implementation by Jeremy Fetvet. And Rodney kind of came up with this idea of recirculating the CO2. And if you could recirculate the CO2 from the exhaust back to the front end through the combustor, then suddenly you had your working fluid, you had your heat transfer fluid in the CO2 itself.
The Allen-Fetvet cycle was revolutionary, the first new working fluid in a turbine in over a century. But proving it would work took years.
We're fortunate in the fact that we were able to survive a very long runway to get to the point that we're at today. That's probably the hardest thing for most startups, is kind of that valley of death.
Eight Rivers helped to grow Net Power in its early years, and then in 2018, they finished building a demonstration plant in Texas to prove the Allen-Fetvet cycle. But even with a working technology, convincing the world was not easy.
Back in 2017, 18, 19, we were talking with people who were already partners, and they were still asking us, why would you design a machine to inherently capture all the CO2? So there still wasn't really full adoption and acknowledgement of the fact that capturing CO2 was the way to reduce emissions from the atmosphere.
But in the face of rampant skepticism, Eight Rivers forged ahead.
Our focus at Eight Rivers was to start that physical infrastructure scale asset innovation process again, which is very difficult. And so how you get through that process, I think one, the most important element is persistence. And then the second item I think is very important is that the technology you've developed has to have a very strong value proposition. So it has to be better economically. It has to be better technically.
Now, Eight Rivers is taking that mindset and applying it to its hydrogen technology, 8RH2, and other technologies like direct air capture and carbon sequestration. And it's still licensing its Allen-Fetvet cycle to Net Power. So I asked Damian what he's learned about building big clean energy projects, about what it was like to launch Project Cormorant, and what scaling challenges Eight Rivers still faces today. So you successfully deployed the AFC in the Net Power project, and now you've moved on to Project Cormorant. So can you talk about moving from electricity production into hydrogen production, and what was the genesis of this project that you're building?
The project in Port Arthur, Project Cormorant, is based around a direct-fired, what we call CO2 convective reformer. And so it has a looping CO2 in it, similar to the AFC, where we're utilizing the CO2 in this case to transfer heat to what we call the CO2 convective reformer, rather than doing work through a turbine. So in the AFC, you're doing work through a turbine, then you're transferring heat. In this instance, we have a combustor married into a reformer. That reformer is using hot CO2 to drive the reformation of natural gas and steam into hydrogen. And then the cold CO2 is coming out and recycling back to the combustor, and we're able to take a slipstream of pure CO2 out of the system for sequestration. And so we looked at the hydrogen market and we said, well, the hydrogen, for the sake of hydrogen, doesn't seem to be working. You need to have something that's consuming hydrogen. And you hear a lot of people talk about, the future hydrogen market. And we kind of looked at it pragmatically and said, well, there is an existing hydrogen market. And the existing hydrogen market centers around ammonia production and refining. Those are the two largest consumers of hydrogen in the world. Let's focus on how we can engage in those industries. And that's when we decided we were going to apply the AIDR-H2 system, which is our blue hydrogen production system, for the production of ammonia. And so we chose a site in the Gulf of Texas at Port Arthur that had port access so that the ammonia could be shipped out to other parts of the country or other countries, and began the development of that project around that new technology.
And is your plan to produce hydrogen or to fully produce ammonia? Are you working with a corporate partner on this one?
We will be producing hydrogen. That hydrogen will go into what's called an ammonia loop to produce ammonia. So because we're doing oxycombustion, we need an air separation unit. That air separation unit will give us oxygen, but it also happens to separate out the nitrogen from air. And to make ammonia, you need two things. You need hydrogen and nitrogen. We already have both of those components coming out of the AIDR-H2 system. And so you add an ammonia loop on the back end, and then you can synthesize the ammonia. And we're working with a company by the name of Casale, who specializes in ammonia production technology, as well as other kind of nitrogen and ammonia product synthesis.
So say more about the origins of this project. So it sounds like one of the first things you did was to figure out a site, of course, after you're characterizing the economic potential for what you're building. What else did you do at the very beginning?
Before you start a project, in our DNA, what we focus on is offtake first. And that offtake for that ammonia, the demand for the ammonia that we saw was coming from Korea. And with SK as an investor in 8 Rivers, it became very likely that SK would be off-taking the ammonia from the project. Well, then political dynamics shifted, and we started putting a lot of time and money into the project. And then the political winds started shifting and timelines became longer. And suddenly this urgency to deploy that was once present, it became less urgent. And so we had more time. But also in this time, we had to work on finding new partners for the offtake of the ammonia, which we've had some success in doing. The project is structured to produce 900,000 tons of ammonia, and we've found offtake for about 18% of that 900,000, and we're working on getting the rest of that ammonia offtake secured.
So let's back up to the beginning again. So you're in the sort of early development phase, and SK has invested in 8 Rivers as a company. Did you also get them to start investing directly into like a project special purpose vehicle to do the development work, or were you taking that on at 8 Rivers?
What you just mentioned about the special purpose vehicle or project entity investment, that is our traditional model. In this instance, we took the capital in through 8 Rivers Topco, and then we used our own capital to develop the project, because the initial thesis was that we would own as close to 100% of the project as possible in order to receive the majority of the revenue.
Okay, so let's say a bit more about some of the things that wound up changing. So you mentioned that some of the policy winds started shifting, and this affected, ultimately your offtake agreement with SK, in addition to how you sort of phased the development and the speed of development for the project. So can you say a bit more about what those policy winds were? Are you talking about in the US or Korea or both?
I would say on the Korea side, both in Korea and Japan, both countries, to their credit, have been significant advocates around lowering emissions, as well as utilization of alternative fuels, or so-called zero carbon fuels. So those are fuels that don't contain any carbon molecules. So ammonia, if you produce it from some low to zero emissions hydrogen, you effectively could import molecules that are not importing any inherent or baked in CO2. And so they've been really strong proponents. So in the US, with the CO2 infrastructure that we have and the ability to utilize CO2 and the appropriate geology for sequestration of CO2, we've been really good around developing policies to incentivize the capture and reduction of CO2 emissions. On the other side, they also have policies around CO2, but have also put in place policies to support the import of cleaner, lower carbon ammonia. And those policies required certain decisions at the government level. And just like in the US, where a bill will be introduced but doesn't necessarily move fast, or even if it's passed, its implementation doesn't necessarily go quickly. I think that was the case in South Korea, where the government needed some more time to further perfect its policies. And so that ended up delaying things a bit.
So can you describe the moment when you found that out? So you were, initially moving into this project, you had already done a significant amount of development work. You were on a certain pace and track to do this. What happened? Did someone from SK call the company and just say, we're going back on this? Was the contract sufficiently ironclad that there was a penalty associated with that? How did that feel and what did it look like?
There wasn't a firm offtake contract in place, but that moment was one of kind of panic and a feeling of desperation and devastation because of the amount of time, energy, and money that had been put into that particular project, because we were trying to do it so quickly.
So, Eight Rivers' biggest offtake contract for Project Cormorant fell apart. And as you heard Damian say earlier, the company always secures offtakes before moving forward with its projects. So, what did Eight Rivers do next? More about that after the break.
The opportunity we found was that we could optimize, because the optimization only came after that of the 8RH2 system. And I don't think we would have implemented the optimization if we were still in that tight timeline. And who knows what we avoided by going to the better system with lower risk. We could have built the project and, it could have been a disaster, where now we have a technology that's much lower risk, has kind of inherent failure modes where pieces fail. We actually have mitigation built into the plant, where the plant can continue producing revenue even if one piece doesn't operate exactly how we want it to operate. And so that, I think, is a significantly positive outcome for us.
So now you've kind of slowed down some of the processes and the burn rate on all of this, but you're still making progress on permitting and transportation and working on securing offtake with a target of breaking ground in 2027. You've also already got some strong lessons learned around the permitting side of things. So can you say a bit about what you did early on in terms of the permitting process for this project and what kinds of things happened?
Yeah, so when we were going out to purchase the land, a key concern was around the feasibility of achieving all the permits that are required for the site. So when you need right-of-ways for pipelines, are you in a jurisdiction where the local government and the state government are going to be supportive of that infrastructure? Further, and even better for us, was the question of where can we locate this project where it has minimal impact, because there's already a lot of existing infrastructure in place that we can work to leverage. And so that's why we really liked Port Arthur. But, as with just about any project, you get into it and you start the permitting process and you start to find these little details within the project. There's a particular stream where there was already some CO2 pipeline going over that stream, and we weren't sure if we were going to have access or get the permit to be able to put another pipeline across it. And, we were able to kind of work through that and understand where that sits. And then, things around the wetland permit, because it's a designated wetland, and whether we were going to be able to kind of modify the site in a way to be foundationally sound. All that was solved. But, in those moments, again, come the moments of panic and exasperation and worry, and why didn't we know this sooner? But I think a lot of these things were difficult to know through the simple diligence process of the property.
Do you remember any specific moments where something happened that just knocked you off your chair in the context of the permitting process and surprised you, especially given that you're in Texas, right, where there's a relatively favorable regulatory environment for infrastructure?
I think it was this stream that already had an existing kind of pipeline bridge. There's probably a more technical and proper term for it, but it was basically a bridge that allowed pipelines to set on. It wasn't a bridge for transport of vehicles or anything, but I think we just assumed that because there was stuff there that we would be able to add another one, but it wasn't so easy. So that was probably the closest of the issues, but it ended up that was workable. So
I really want to ask you for a second about the turbine development. It's really hard to build small turbines and have those be effectively representative of the large system. So, can you say a bit about how you all thought about the initial turbine development? And let's just start with some of the basics around what were you able to do kind of in house within Eight Rivers? And at what point did you need to partner with the global turbine manufacturers to make these things happen?
Yeah, so for us at Eight Rivers on the solid fuels front, we own and retain rights to all solid fuels. And where we chose to partner was with Siemens Energy. We really liked Siemens Energy because they've been building turbines for a very long time, over 100 years. And they had some of, the best gas turbines in the world. They, I think, have the second largest market share of turbines deployed across the world of any OEM. They have experience in high pressure or ultra supercritical steam turbines, which are very high pressure, like the turbine we need. They've also have enough time under their belt where they've seen how they fail. So it's one thing to know how to design. It's even better if you know all the ways that they fail. And so those two combinations, I think, make them ideal. Internal to Eight Rivers, we do not have the expertise. Well, we did not have the expertise. So what we did with the AFC was we assumed an inlet condition, we assumed an outlet condition for the turbine, and then designed the rest of the plant. And then we went to the different turbine OEMs and said, these are the conditions. Can you design something to this? And that process of searching for the turbine OEM has proven to be one of the longer efforts. But I will say, right now, Eight Rivers is in a very good place with Siemens Energy. With all that experience, what we love about them is that they don't see the need to build the smaller one. They can get all the components tested and develop a low enough risk turbine that can be deployed in the first commercial plant. Now, is it going to be the highest efficiency AFC turbine that could ever be developed? Well, absolutely not. What we're focused on is how do we get a machine that is reliable, that is predictable, that is safe, and that future improvements can then be applied to. And they're a group that is capable of doing that. They have a huge service footprint across the world for servicing these turbines. So that's very important. And then the other great thing about them is they also produce generators. And one thing we were very focused on was the OEMs that can do both, produce the turbine and produce the generator, because they have to work very well together when you bolt them up. And that's something that Siemens does. And then Siemens also has the transformers. They can do the switchyard engineering for, doing the interconnections to the electrical grid. And then they happen to produce a whole bunch of other equipment that we can utilize across the plant, compressors, other electrical equipment. And then also they have the ability to develop control systems. So how you operate and control the plant through a software system, and they have that capability as well. And so it wasn't just the turbine, it was the generator, it was the transformers for getting the electrons to market and then operating the plant. When you look across all those things, Siemens is one of few that can do all of them.
Okay, but let's go back to the beginning where you were trying to convince these turbine manufacturers to effectively work with you and to build this thing for which you had defined the conditions. So how did those conversations go? What was the proposition that you were bringing to them, and what was the initial response you were getting?
The proposition was that these AFC systems were going to be the lowest cost systems that produced reliable 24/7 electricity, and that there were other operational characteristics that would make them more competitive than any other type of generation on the market. The other characteristics is complex, and we don't need to get into it too much, but like ancillary grid services like spinning reserves and peaking capacity and energy storage capacity and frequency regulation, those are all things that AFCs are uniquely capable of, in addition to just producing power. And I think they can provide those ancillary grid services in ways that other systems can't, or might only be able to provide one or two of those services, where we see a path where we can provide all four, and where in other gas turbines or steam turbines you would have to make some modifications or run the plant outside of its ordinary course of operations, where we can run within the ordinary course and still provide those services. So the reason I go into that was the value. It was the value proposition that we were saying, listen, these systems are the next generation of turbine. And there was also a very strong argument on the environmental side and the elimination of emissions, and that this was better than using adsorbents on turbines. And so that was the argument. And with Siemens Energy, it goes all the way back to 2016 is when those conversations started. And so on their side, it was a lot of, one, the initial questions were, well, is there a market for CO2? Why would we build a machine that does all this CO2 capture? If it's lower efficiency than our best-in-class gas turbine, why would we ever do something that's lower efficiency? We really had to work for years on getting the turbine manufacturers to understand that turbines aren't just about thermal energy to electrical, that there was a broader value proposition to these turbines. And so that was a lot of the work. And then the other piece, it comes around the designing of a new piece of machinery and the belief as to whether they could technically deliver. To the credit of these organizations, what they aren't willing to do is stand up and say, yes, we'll develop something for you if they themselves don't believe it can be delivered. And so I think they wanted to be sure that it could be delivered. So one, they wanted to know, what's the market? Why do it? Okay, fine, market's there. Now let's ask ourselves the question, do we believe that it's technically viable that we can manufacture and deliver this design, manufacture, and deliver this turbine? And you might be able to design it, and theoretically you could deliver it, but you might not. Maybe there's some manufacturing piece that is impossible. And so once all of those things came together, what we saw is that there were a few in the market that came to the table and decided to step up to the plate to design the AFC turbines.
And so just to be clear, are you offering to pay them anything? Because I think a lot of times the way startups work with it's like a contract manufacturing thing, right? Like, go build me this. And the company says, well, as long as I can deliver on this contract, sure, you can pay me to build anything. But this is different, right? So were you offering any sort of contractual revenue or equity or anything to these folks? Or was it literally just trying to convince them to do this development on their own on the assumption that there would be a market for these?
Yeah, so for 8 Rivers and Siemens Energy, yes, there certainly is a contract, and it's a commercial contract, and so there's compensation. I will say, internal to Siemens Energy, this is the largest development program they've ever done in their history, in partnership with an outside group. So they have over 200 engineers working on this program. I would say about 100 of those are full-time. And so, yeah, it's a significant commercial undertaking.
And so they're taking on some of the risk of this too, then, at least to an extent, it sounds like. Is that right?
They certainly have skin in the game, absolutely.
So with all of this work, going out, really working on convincing effectively these turbine manufacturers to work with you over the course of many, many years to finally come to an agreement with Siemens. Interestingly enough, Net Power, now an independent company, has decided to partner with Baker Hughes to provide their turbine. So can you say a bit about why that happened and what you think are some of the, benefits and costs of the fact that there are effectively two folks working on this particular turbine structure?
As far as Net Power's decision to work with Baker Hughes, that was a decision they made as a company themselves. By that time, they were employees of Net Power, and they were empowered to kind of make those decisions, and that was their recommendation, and they ultimately decided to go forward with it. And I think, it was a timely one because it wasn't soon after that decision that they went public. And so, again, that hindsight example, it was the right decision at the time for sure, and probably the right decision in the long term as well.
Yeah, I want to know what you think are some of the implications of this decision. So now there are effectively two of these companies working on this turbine.
Oh, yeah, I think, sole source dependency is always a huge risk. You never just want to have one manufacturer of a particular thing. You always want to have a diversified supply chain. And so I think having more than one turbine developer in the AFC realm is great. Those turbines are probably very different, but nonetheless, they're working with a similar fluid and they're burning carbonaceous-based fuels. And all that kind of points in a direction of the AFC being able to be deployed more widely and being able to deploy more quickly.
Looking forward, where do you think Eight Rivers is going to be in terms of serving the broader ecosystem? What do you think is kind of the future direction for the company?
The ultimate goal of Eight Rivers is to have caused more CO2 to be captured than any other company in the world. And have caused is an important part of that statement because that doesn't necessarily mean that it always has to be our technology. We want to see a whole bunch of companies in this space be very successful. And, we've partnered with some post-combustion carbon capture companies. We've partnered with other organizations, and we want to see those technologies be brought to market. And we think we have, beyond just technical innovation, business model and business structure innovation that can help, especially in the CO2 space. And so we want to see that get put to work. I would call success for us being that by 2040, we see a majority of the systems in the world that are being deployed that are consuming fossil utilize CO2 oxycombustors in some form or fashion and use that CO2 as a heat transfer fluid or working fluid in industrial systems. I think it would be a huge win for society, and obviously it would be a big win for the Eight Rivers organization.
Okay, last question for you. If I wired $100 million into Eight Rivers' bank account tomorrow, what would you do with it?
With that $100 million, we would achieve FID on both Cormorant and one of our AFCC projects that we've announced with NTEC or Pacific Corp. So with that, we would achieve FID and break ground on both of those projects.
That sounds exciting. I'm someone here who is officially a fan of steel in the ground on clean climate projects. So I wish you all the best in your work. Thank you so much, Damian, for joining us.
Thank you.
Damian Beauchamp is the president and CEO of Eight Rivers. The Green Blueprint is produced by Latitude Media in partnership with Trellis Climate. The show is hosted by me, Lara Pierpoint. This episode was produced by Aaron Hardick and Daniel Woldorf. Ann Bailey is our senior editor. Sean Marquand is our technical director. Stephen Lacey is our executive editor. If you'd like to suggest topics or guests for the show, send an email to thegreenblueprint@latitudemedia.com. You can listen to The Green Blueprint at latitudemedia.com or subscribe wherever you get podcasts. And if you have fellow clean energy or climate tech travelers who would benefit from the insights in this show, send them a link. This is The Green Blueprint, a show about the architects of the clean energy economy.